Mr. Dietrich, more chemistry cool stuff. Today, though, start off with best birthday gift.
Mine's a no-brainer because 2 years ago on my birthday, my baby daughter was born. So.
Oh, nice. And I was thinking something much, much more tangible. As a kid, maybe 13, 12 years old, bicycle. Yeah, it was a bicycle, 10-speed, the old 10-speed. Yeah, I was pretty happy with that. So today, folks, we're going to talk about sig fig calculations. So we learned about how to count sig figs in the last video. Today, we'll learn how to do it with calculations. Mr. D, take it away.
Well, probably the best thing to start with is let's do an example of why we care about accuracy in significant figures. So let's pretend that Mr. Bergman and I were going on a fishing trip, and I've been watching a lot of ESPN, 2 at 3 in the morning, and they have these fishing competitions. And let's pretend our fishing competition is simply this: we have 2 people fishing, and we're against a bunch of other people. We add our 2 fishes together, together, and whatever our combined mass is, that's our total, right? So I have a very old school, those little hooks that you put the fish onto and it pulls down a spring. So let's say I do mine on that little hooks thing, and when you measure it out, my fish weighs 1.2 kilograms.
And of course, for me, I caught a bigger fish because I'm awesome. And I went and I bought one of those fancy electronic balances that we've seen in our lab, and mine weighed 12.235 kilograms.
Clearly. Now, if we were to add up both of those together, let's add them together. We line up the decimal.
12.235 and 1.2. Now I can do that in my head. 5, 3, 4, 1, 3. 13.435 grams. If I got my calculator out, right? Get the calculator out, that's what it would tell me the answer is, but that's really not the answer, is it?
Yeah, if we were to submit that as our total to the judges, they'd be like, liars. And here's why. What have we assumed, Mr. Bergman, is behind the 1.5 to get that number?
So we don't know what these numbers are. We're making an assumption they were zeros, but we don't know that they're zeros because your scale sucked.
Yeah, my scale didn't have those. So if I record that number down below, the reality is that we didn't record that. That's a lie.
Right. So what we have to do, folks, is that we have to round to the most or the least accurate measurement. And so if you look, the poor measuring device that we had here, you're going to round the least accurate measurement. So all we can say is 13.4 because the 3 and the 5, they mean nothing. So, by the way, if this had been a 5, right, you would round the 4 up to a 5, right? Because if this is something higher, or 6 or a 7 or something like that. So that leads us really to the first, if you will, rule when you add and subtract significant figures. So that has to do with addition and subtraction. What would you say, Mr. D? What's the rule?
So for adding and subtracting, the rule is line up and count columns. And probably the best way to do this is by doing another example, yeah?
Okay. Yeah. Let's do one.
So let's try 14.07 plus 0.106.
0716?
0.106. And you
Okay.
notice what Mr. Bergman did is he lined up the decimal places, which is the first thing you have to do every time you do the math. Then what you're going to do is you're going to just do the regular math. So add up everything first.
14.176.
And then what he's done already is this. You're going to count columns going from the left-hand side to the right, and we're going to see which columns have numbers, significant figures in both. And we're going to notice he wrote the number to the line. We call it the line O death, to the right-hand side of the last column that has significant figures in both. So if you take a look, you see how the 1 and the 0 match up with the 0 and the 7 up above. So right after the 7 and the 0, you have to put the line of death, which means only the numbers to the left-hand side of that count. But there is something else here, and Mr. Bergman mentioned it last time. See the number next to the line of death, that 6? It's going to be dead. We're not going to be able to write it, but we're not.
But it did round the 7 up to the 8. So so because if
it's going to round it up.
But now that was add and subtract. What about multiply, divide?
Multiplying and dividing is actually way easier because there's only one word we have to worry about, and that is least.
Least what?
Least number of significant figures. So whenever you're multiplying or dividing, two numbers. Whatever number has the least number of significant figures, that's how many you're going to put in your answer. So,
All right, so let's do it. Okay, what example do you want to have?
Let's go 721 times 12.
All right, so I've got my trusty dusty calculator out here, 721 times 12, and I get that equal to 8,652.
So if we take a look at this here, how many significant figures do we have in the first number that we looked at?
Well, there's no non-zero digits, so that's 3. Same on this one, this would be 2 because there's no non-zero digits. So least, that means I need to round this to 2 significant digits. But I've got 4 digits. How in the world am I going to do that?
That's where it becomes a little bit crazier. So what we do is we count from the left 2 spaces over. So we go 8, 6, and then we draw a line of death after that.
Mm-hmm.
Now, what that means is that the numbers to the right
don't count. But I can't say it's 86, because if I say 86, or actually the 5 would round, I could say 87, but 87 is even close to 8,652. How do I write that out?
And you're absolutely right. And this is where we have to use placeholders. So placeholders, they mark where numbers once were, but we just don't know what they are because we don't have the accuracy. So in this case here, 87 is not the same as 8,650, but if we wrote 8,700, that would...
So this is the trick, folks. When you do 8,700, you see this is important. 8,700, this is, because we now have, this was a sucky number. So we have to round only to 2 digits. So all you can say, it's around 8,700. It's not 8,650. Don't always believe what's on your calculator. You have another example?
Yeah, let's try another one. Let's go 34.5.
34.5 or 3.45?
34.5
Uh-huh.
times 3.1.
Okay, we've got 3 digits here and 2 digits here. So let me get the 34.5. Oh, you know the answer? What does that come out to be on the calculator?
106.95.
Okay.
So start counting from the left, and we're only allowed to have how many significant figures in this case?
2.
2.
So boom, right here.
If you wrote the answer out, we're only allowed to have 2 significant figures.
We'll just say 110, because the 6 rounds up to 0, and that's going to be strange. That has 2 significant digits, right? Yeah. Now, is division any differently? How would you do a division problem?
Well, the division is exactly the same, but can I come back to that just for a second? The
Yeah.
other way you could do that is by doing scientific notation. So you wouldn't have to worry about trailing zeros at all. If you take that decimal place that you had in the original number, so the 106.95,
Yeah.
slide the decimal place over 2 places to the left.
Well, I only know 1 place. Yeah, 2 places left. Okay.
And then you'd end up with 1.0695. So write the whole number out.
Oh.
You wouldn't mind? Just so we can show how we get that. And then what we can do is we can just cut the line off after the 2 significant figures, and we wouldn't have to worry about dealing with placeholders or anything like that.
But I wouldn't use 1.1 times 10 to the 1. I would never write a number like that. I mean, unless it was like a big exponent. I'm not going to do it that way, I don't think. I mean, if I had a big number, the only time we'd ever really want to use scientific notation, unless you got a super big number or a super small number, which does happen, of course.
Yeah, that is correct. It should be times 10 the 2, though.
Yep, you're right. It's 10 second. My bad.
But you're right. You're absolutely right. There's no reason to do that, but I just want to point an alternate out because numbers, you might have to do it that way.
So, folks, let's try one more example. Let's say I've got 55.25 grams, and so this is like a density problem, and I would divide it by 23.0 milliliters. Okay, so this is grams per. This actually would be a density. So let's take my trusty calculator, and I'll take 55.25 divided by 23.0, and I get this number, 2.402173913. I get a big old number. You can only keep least, right? And so this one right here has 4 sig figs. This one has 3 sig figs. So I'm going to go to the 3rd decimal, boom, right here. So it's 2.40. Now there's this 2 right here, but 2 is less than 5. So the answer is 2.40 grams per milliliter. You see all these numbers. So the moral of the story is don't believe your calculator. Your calculator is going to give you a million digits, but we don't know what those digits are because the 23.0 is the best measurement we had in terms of it's only had 3 significant digits versus 4. Now in class, you're going to be working on doing these on your own, and you'll probably get stuck. It's okay. These can be a little tricky and a little hard, but you'll get this because you guys, well, you're awesome. You're from Houston. What else, right?
Yeah. And you notice here, he divided grams by milliliters. We're going to talk about how we divide and multiply units because we do the same exact thing for the units that we do with our exponents. The problem is that grams and milliliters are 2 different units, so there's no way to actually subtract them because that's what we do with units. But we'll talk about that when we do a few more examples later on.
We'll see you in class.